Hello friends, so today in this video we will be discussing the first video from the latest AtCoder regular contest 116 problem name odd versus even. So I thought this problem is some sort of mathematical problem. So we're going to discuss this problem, how to understand such type of problems. So the problem statement states that given a positive integer n, like some integer n is given to you, you have to just find out whether that n has positive odd divisors more or positive even divisors more. So you just have to find out the divisors, what are the numbers which divide that number, and whatever is the number, just any number which divide that number is a divisor. Then count out how many all the positive odd divisors and even divisors are there for that n, and then you just have to tell that whether the divisors are even the numbers. Even means that both the odd divisors and even divisors are same, or the odd divisors are more or the even divisors are more. So it's in simple terms, you just have to find out all the divisors of any number and just tell that whether the count of the odd divisors are more, the even divisors are more, or they are same. And as you can see, the test cases are also there and n is also pretty large. So now the easiest way to find out the divisors is in under root of n. Okay, so like you just iterate over from 1 till under root of n, and then for every number just find out that whether it is divisible by that number or not. So as you can see, that n is pretty high, and then also it has t test cases, so you cannot do this in that manner. You cannot find out divisors even more further, like even in a more faster way, and also n is very large, you cannot find it for every number. So it means that there might be some another way to find out the divisors. And also it's a problem, so it not might be too difficult to find out some like test cases or some examples. So let's move on to the drawing board to understand some of the test cases what you can see. So what the first thought come to our mind is, let's just take a random number, but don't write it as a number, just write it as some divisors. So as you can see, let's assume I have 3 into 5, which is 15. So as you can see, if it is a 50 number, the divisors of this number is 1, 3, 5 and 15, which are all odd. So because the numbers are formed using these numbers, if you take out any subset of numbers, because to find out or to form out any of the a divisor of any number, you just break it down into its prime factors, and just take out some subset. If you take out some subset, that will eventually form a divisor of that number. But because all the numbers are odd, the subset will always be odd, like all the numbers will be odd only. And thus, if any number has any even 2 in it, if any number has a factor of 2 in it, it will become even, and then there will be some even factors also. But if there is no 2, or the number is odd, if the number is odd, then all the factors of that will be some odd numbers, and if you take out any subset of those odd numbers, the factors will be all odd. So it boils down to that if the number is odd, all the factors will be odd, and thus obviously odd factors will be more, so odd divisors will be more. So it means that if the number is odd, the answer is the odd divisors are more, so the answer will be odd. So as you can see, you can check it also with the test case. This is odd, so this is odd. Okay, so for even it is different, so obviously it is same or even, we have to check. Now let's take out some even number. So how we can form out some even number? We have to just put a 2 and then some more 2's, or some 2 to the power of 2, and then some. So we'll start with some smallest number. We have just one factor of 2, and then some factors of odd. Let's do. Now if you want to find out all the factors in this number, what the number is 30, what you can see in this problem is what you can do here is, how I just told you that you have to find out any subset of this number, and then that will be the factors, divisors. So let's first see out all the factors. It is 1, then it can be 2, then 3, then 5, then 6, then 10, then 15, and then 30. I hope these are the numbers. So now as you can see in this number is, there are some numbers which are even, there are some numbers which are odd, and in this case both are 4. Like it is same. The number of factors which are even and the number of divisors which are odd, they are both are equal in frequencies, and the answer is same. So why does it comes out to be same? That's what I have come to my mind. So I just thought that, okay, how we can find out what are the factors which are even and which are the factors which are odd. So because we always take out some subset, let's just remove out 2. Just remove out 2. And then the remaining factors will be some odd numbers. Now because I'm assuming that there is only 1 2 in this number because it's an even number. It can have also more 2's, but in this first case just assume that it has only 1 2, and there are some odd numbers. So if there are some odd numbers, it boils down to the previous problem. All the subset we can take out from this number, they will be all odd. So okay, so all the factors, if you just take out these numbers, all the factors which you can form are odd. Okay, now the other possible case can be, because you have to also incorporate 2 in these cases. What I mean by this is, let's assume that these are the numbers we have. I'll just read it out to even make it more clear. Let's assume my factors are 2, 5 and 3. Okay, if I take out only these 2 factors which are odd, I just take out odd factors. The subset which I can probably form is 1, because there is 1 also, then 5, then 3, then 15, which is fine. But now these are not the possible answers because my number is 30, it's not 15. Okay, so now if I want to find out the possible factors, then for every number it has 2 cases, because I can either multiply this number by 2, which means that I can either put this 2 in this set, or I do not put this in this set. I hope you understand, because see, it's just like forming a subset now. I'm just taking out some subset of these numbers which will eventually form a factor. So I can either put a 2 in this set. So these are different sets now. So either I can put a 2 in this set, or I cannot put a 2 in set. If I put this in a set, it will form 2, which is a factor. If I do not put this in a set, it is 1. If I put this into a set, it will become 10, which is a factor. If I do not put it in, it will become 5. If I put this, it becomes 6, which is a factor of you just understand the factor, the number is 30 only. If I do not put this, the number will be 3. If I put this, it will become 30. If I do not pick this, it will become 15. And these are the possible 1 2 3 4 5 6 7 8, the 8 factors of 30. So it means that I have just taken out the subset of the odd numbers, and then there are 2 cases. Either I can put a 2 in those numbers, or either I can do not put the 2 in those factors. So there are 2 possible cases. And if there are 2 possible cases for every odd, because all the subset which I will be forming from these numbers will be odd, and if I multiply an even number with that, then obviously that will result down to an even number and an odd number, even number and odd number, even number, odd number, even number, odd number, and so on. So it means that they should be equal. So if there is only 1 2 in the number, then obviously it can boils down to giving an even number, odd number, even number, odd number. But let's assume that I have more than 2 2's. I have again one more 2, which will lead down to a number 60. If I do the same thing again, I just take out all the odd factors and all the even factors. So I have the even factors 2 and 2, and the odd factors and 5 and 3. Cool. Now what you can do the same thing if you boil down all the odd factors into different subsets. So I have one subset which is 1 5 3 15. Now I have possible cases in which I can either put a 2 with this, and it will again lead down to 2 factors, which will eventually give me even frequency. So it is not more. Okay, now if I again put a 2 here, so it is the same case, so I don't have to care that again. If I again multiply it with a 4 number, because 4 can also be a subset, like I have to take out all the subsets from here and multiply with all the subsets from there. I hope you get the point. So all the subsets in this point is, because I've taken 1 here, so it can be like, or like it can be, possible subset can be 1 2 4, and the possible subsets in this case can be like, as you can see, 1 3 5 15. Now what you can like easily see in this problem is, like these numbers, like it has like these cases. The first case can be, in the first case only, it will boils down all the even cases. Like it will give me all the see, I have two cases now. I can either multiply with the 2. So when I also have two numbers only, like I have a factor of 2 and the odd numbers, I have two possibilities. I can either multiply it with 2 or I do not multiply it with 2. It means that I have two factors of 2. I have 1 and 2. So I will multiply all the subsets of this even numbers with all the subsets of odd numbers, and that combination will form the possible all subsets. So I can either multiply with 1, and if I multiply this one factor with all the factors of the odd numbers, then eventually it will give me all the odd factors. If I multiply this with the even factor, then obviously it will give me the even factors. But now I have these factors on the even side and these factors on the odd side. If I multiply with 1, then it will eventually give me all the odd factors. If I multiply with 2, it will give me even factors. If I multiply with 4, it will give me even factors. So it means that now if I move forward from 2, like 4, 8, 16, because they are 2 to the power of n numbers, and then I multiply with some odd factors, obviously there will be more factors ahead like this, which are on the even side. And when they multiply with the odd side, they will eventually be forming more even factors or like even subsets, and thus the number of even divisors will increase. And in that case, the number of even divisors increases, and thus the number of even divisors is more. So there are three cases. The first case is if the number is odd, it's eventually giving you odd answer. If the number is having only a number which is 2 as a divisor, like there is only 2, like the number 2 is there, which is in the divisor only, like which is only multiplied by 2, so the answer is even, like equally divided. But it has a number which has a power of 2, so you just have to find out the power of 2 in that number. If the number has power of 2 which is equal to 1, then obviously the answer is equal to even, or like even number, but it has equal balance. But if the power of 2 is greater than 1, which is like 2, 4 and like 2, 3, 4 and so on, then the answer is obviously like even divisors are more. And that's the whole logic for this problem. You can even code it out. The code is also very simple. You just have to find out the like the power of 2 in this problem, and that's it. So you can easily find out because there are 18 steps, like you just have to find out the power of 2 in this number, and that's it. I hope you understand the logic and the code for this problem. If you still haven't, you can mention in the comment box. I'll see you next one. Till then, keep coding and bye.